Hi, welcome back to our Windows Server 2016 course. For today, we will cover the compute module. So far, we have covered the following modules: introduction, platform vision, management, security, identity and access, storage, networking, and we started with the compute, and we covered nano servers and containers. So for today will be main focus containers. Around containers we have again 6 areas to cover: overview around and fundamentals, Windows containers basis, Hyper-V containers, supported OS, Hyper-V container host requirement, Docker engine for Windows, and some learning and recommendation around Docker. So let's start. Before, as the resource became more and more powerful, often the application did not utilize even fraction of the resource provided by the physical machine. Thus, virtual resources were created to simulate underlying physical hardware, enabling multiple applications to run concurrently, each utilizing a fraction of physical resource at the same physical machine. So, with Windows containers provide operating system level virtualization that allow multiple isolated applications to run on a single system. How do containers differ from the virtual machine? Containers OS virtualization, where each virtualized app includes the app itself, required binary and library and guest OS. Virtual machine it's a machine virtualization where each VM simulate the underlying physical hardware. So you can see the physical computer in another analogy, or another example will be a physical computer before we used to be able to host, from application point of view, one app with its own dependency libraries and uh, drivers, for example. And then if the app getting updated, we were not able to host the latest update with coexisting with the previous one with different dependency. We had to uninstall and reinstall it. Then we had the phenomenal update toward the VM on a hypervisor, which means we have one physical box and can host so many or many VMs, and these VMs can host different application, which means we overcome the limitation related to the one-to-one contention toward many-to-one. And then we evolved toward the containers. With the containers we were able to host many VMs on a physical host, and each VM can host many containers. So in another word, containers, they are the virtualization for application, similar to the Nano. If you recall earlier, we mentioned Nano could be a portable OS because it's quite small, it's tiny, it's utilize less um, resource. Hopefully that explanation give you the better understanding around the difference between VM and containers. Let's have a look at some of the fundamentals. Container host, it's a physical or virtual computer configured with container image, container OS image, first layer of the potentially many layers that makes up the container image, and sandbox, a layer where write actions such as file and registry modification and software installation are captured. Container image, base OS application and application dependency of a container and container repository, local storage of image that can be reused on the container host. Container registry, where images are stored and can be downloaded on demand, like Docker Hub, and Docker files instruction files used to automate the creation of container images. These are the fundamentals around basically Windows containers. With container management technology, Windows container can be managed using either PowerShell or Docker. With either one of these tools, you can create new containers, container images, and will also manage the container lifecycle. Uh, Next is the difference between the Windows containers. Just before we start to talk about Windows containers technology quite old, so it's nearly 20 years old, and then it evolved from the Unix platform toward 2008 around Linux adopting the containers, and then Microsoft now giving us the containers on the Windows platforms. Now, with Windows containers versus Hyper-V containers. The first Windows containers or server containers will be shared kernel architecture, isolation provided through namespace and process, isolation technology. For the Hyper-V, separate kernel architecture, isolation provided through the Hyper-V. Each container is run inside of utility VMs. So we can see the difference between the two architecture. One with basically sharing the host and no dependency and no libraries, and the second is basically even the kernels are not shared, which is the Hyper-V approach. So if you see after isolation, then that will be the Hyper-V approach. With Hyper-V containers, or before the Hyper-V containers, let's we talk about how that basically works. With a Windows container, it provides OS level virtualization that allow multiple isolated applications to run into a single system. It addresses density and startup performance scenarios and achieve isolation through namespace and process isolation. Process grouping, known as job object in Windows, is a mechanism of classifying and operating one set of processes as a single unit. Job objects have existed in Windows since Windows 7 and Server 2008. Namespace describe a form of virtualization where an OS wide or global configuration can be instanced or virtualized, given a namespace as a reference job. In order for application inside container to work properly, there are a number of namespaces that must be virtualized. Some of the major ones include storage, registry, networking, object table, and process table. Each container has a virtualized view of these namespaces, limiting its abilities to see global properties. Now, the second type is Hyper-V containers. It supports the same features as Windows containers and additionally addresses isolation and kernel variation, lending itself to complex application development and hostile multiple tenancy scenarios. Hyper-V encapsulates each container in a lightweight virtual machine. Shared kernel container environments are not designated for hostile multi-tenancy scenario, while Hyper-V containers are naturally designed for this type of multi-tenancy and have their root in hardware isolation properties. Example of hostile multi-tenancy scenario include highly regulated environment, hosting environments, computing workload. Hyper-V containers encapsulate each container in a lightweight VM, providing the same level of isolation provided in virtual machine, addressing kernel isolation and variation requirement while providing the same density and startup performance associated with a container. Hopefully we know now the difference between Windows containers and Hyper-V containers. Next is each of these high-level fundamentals. We're going to cover them. So the first one is the container host. What are the supported OS for the container host? Windows containers and Hyper-V containers are supported on Windows Server 2016 desktop experience, data center or standard. Windows Server 2016 server core, again either data center or standard. Windows Server 2016 nano servers, and then Windows 10 anniversary update. Licensing is depend on the VM. So Windows containers are limited on standard and data center, and Hyper-V containers too on standard and limited on data center. And you can check with URL and Microsoft what you currently license, if it's covered or not. Second is the image. With the supported operating system for container image, Windows Server 2016 core either data center or standard, and nano servers. For Windows containers, the container host build must match the container image build. This is really important. Next, Hyper-V container host requirement. Hyper-V role enabled. Additional requirement if Hyper-V container host virtualized. Nested virtualization support. Minimum 4 GB RAM and minimum 2 processor. Now, if we decided to use Hyper-V to encapsulate each container in a lightweight virtual machine, then for hostile multi-tenancy scenario, we need highly regulated environment, hostile environment, and computing workload. Let's have a look at the architecture level of these two platforms. Windows containers sit on or interact with Docker. So Docker engine is for Windows. Microsoft work with Docker to provide basically containers on a Windows platform. Docker has emerged as the de facto container experience for customers, and Microsoft has partnered with Docker to provide Docker on the new platform technology 2016. Windows containers is cross-compiled with Linux to provide the same experience and common Docker engine. For customers, this means that Windows containers support the Docker experience, including Docker command structure, Docker repositories, Docker data center, and orchestration. In addition, Windows container extend the Docker community to provide Windows innovation such as PowerShell to manage Windows or Linux containers. Now, while containers are new to Windows, Linux containers have been available since 2008. Docker engine for Windows Server containers developed under the Docker open source project. Docker client uses the same standard Docker client and interface in Linux. Docker Hub is a collection of open and curated applications. Collaboration with Docker brings Windows Server containers to the Docker ecosystem. Installation. Docker engine installation. The Docker engine is required to manage container image. Very simple step-by-step guide can be found on the Docker website, or it could be via PowerShell, as you can see here. Next is some of the Docker engine command line based. You can see there very basic one like Docker port, Docker engine, Docker rm, Docker restart, Docker attach, Docker search, Docker volumes. It looks similar to the old DOS commandlet. PG initially created PowerShell. However, the community consensus was the Docker is the industry standard, and that was better to manage Windows the same OS. The command can be run from PowerShell and the same CMD as well. Base container image sizes. The container host will need space to store the base container image used to create the container. Each container sizes of various images can be seen depending on the roles you will be installing. Here we can see the nano and core around nearly 10 and 10 gig without adding additional resource to it. If you would like to search for some of the Microsoft utility, you can do search for containers image on Docker. Docker Hub registry contains pre-built image that must be used for your base container image. You can see that commandlet Docker pull, and you can specify what image you're trying to utilize. Docker search, and you can search for Microsoft. It could be Docker search, and you can do the same for non-Microsoft platforms, and you will be able to pull it. Some of these are Linux specific, so look closely at the description. When you download with Docker pull, it will warn you whether it can be used on the host OS. Windows Server Container provide operating system level virtualization, allow multiple isolated applications to run on single system, and in order to application inside container to work properly, there are a number of namespaces that must be virtualized. Next is troubleshooting with debug container host.ps1 PowerShell. Runs a series of tests on nano servers, provide Windows version and prereq, Docker installation, user permission, and container settings and container image. Windows Server App WSA is important as it is the official supported server installer going forward, and it's the only installer available on nano servers. WSA is a significant shift from the traditional MSI installer technology. In a recent interview, we've seen some Microsoft technical architect clarifying how WSA declarative architecture help the customers to meet their demands. Containers host must be domain joined. Option to join container to domain with emulated domain join. Group policy cannot be applied, and the reason why to eliminate the overhead. Domain credentials are not stored in the container image. Emulation for domain join require at least 2012 domain and forest function level. That will allow the service of the container to run with the group managed service account. GMSA allow application to use Windows integrated authentication. Since the identity is being provided to the container image as it's deployed, it can be safely stored within the repository and deployed to multiple ID and environments, supporting environments, staging, and production scenarios. Domain credentials are not stored in the container image. Next is some learning resource. You can create your free Azure account, and you can see the links to Microsoft and GitHub and Channel 9, and you can basically improve your experience around containers. That's all what I had for you today. Hopefully you've learned something useful. Before I call it off, let's recap what we have learned about Windows containers. We spoke about containers, and we walked through the comparison between containers and VMs. We spoke about the history of containers evolving from Unix toward Linux and then now to Windows. We spoke about Microsoft working together with Docker to be able to allow customers to use containers on a Windows platform using Docker, and within Docker you can use the same commandlet you are using with Linux. We spoke about the isolation or the differences between containers. We mentioned you can have a containers on a Windows 10 with anniversary update, and on that one you can flip between the Linux platform and Windows. It's like having a virtualized icons and a shortcut on your Windows to flip between the two systems. Then there's another one within Azure, which is a GUI based, but our main focus today was for Windows Server 2016 containers and Hyper-V containers. We mentioned if you are after isolation, segregation, no sharing kernels, then that will be Hyper-V, and we walked through all the prereq for Hyper-V. We mentioned 4 GB RAM and 2 CPUs and Hyper-V role, and then we went through some requirement around being domain joined the containers, and group policy not possible because to eliminate the overhead. And we walked through some of the learning resources via Azure, Channel 9, GitHub, and Virtual Academy via Microsoft. And that's all basically. In addition to that one, I show you how you can run some of these commandlets, and how we can walk through uh, Docker search or Docker pull, and you can get the image you wanted. Also, we spoke about the Docker engine for Windows and Docker client and Docker basically collaboration, and how you can search through the internet, or the Docker open source to pull the right image. And we highlight as well, just to make sure, some of these commandlets might not be possible because they are Linux, and we'll tell you they are not available for the Windows. And we walk through the layers. We mentioned the first layer will be similar across Microsoft, Windows, and Linux. And then we had the daemon, and then we had the Docker sit underneath it. That's all what I had for you for today. Hopefully you have learned something useful, and I shall basically see you at the next video. Thank you for watching. Goodbye.